Hi everybody, so welcome to the next episode of Show Me Your REPL. And my pleasure to have Dmitri Sotnikov. This is serial contributor to open source, author of Luminous, and bunch of other stuff you definitely know. As well, Dmitri is a writer. He wrote the book about Clojure, web development with Clojure, yes? It's a set of receipts and advices how to make web application in Clojure. And hi, Dmitri.
Well,
Yeah, and on our show, so experienced developers are sharing how they're working with Clojure, how they're doing REPL-driven development. So let's share the screen. Let's show your setup, what IDE, what operating system. So I think people are interested in the small details. They quite
yeah, let's do it. So, I predominantly work on a Mac, but I still like my workflow is basically would work the same on Linux. Like I've used Linux before, so it's pretty fluid. What I like to do is I like to run the REPL from the command line from a terminal, and then once the end REPL starts, just connect whatever editor I'm using at the time. For longest time, I've used IntelliJ with Cursive, and I find like it's pretty solid setup. But lately, I've actually switched to using Calva because I feel, yeah, like I find the thing I like about VS Code is it starts up like really fast. It's less resource intensive than IntelliJ, and now that we have stuff like CLJ Condo, a lot of the telemetry that you would get out of Cursive is now available through Calva, so you can get, like it highlights the functions unused, like if you have wrong arguments, you can do auto renames, search for definitions, so kind of like all those common things I've come to expect from an IDE, I've come to work with that. It's still not perfect. There's like kind of a few glitches you get once here and there, like, like formatting is wrong or it gets in a weird state, but for the most part, it's pretty stable. I find it gets a bit worse with large projects, but lately the way I try to organize my code is to keep things small intentionally. So it's kind of a good rule of thumb for me. Like if it gets too big for Calva, like maybe I should break it up. So I use that as a feature. And yeah, I find for the REPL itself, nowadays, I really recommend Babashka. So right now I have actually Babashka REPL running right here. It's getting like a bit confused, but still working. And actually, let me start it up. So basically, anytime I do kind of like a small script or something nowadays, I no longer use Bash. It's always Babashka. And if you're not familiar with it, it's basically, or I'm hoping most people are familiar in GarageBand nowadays, but it's basically like an alternative implementation that's compiled with GraalVM. So it has like very quick startup time. If we run it, right, like that's it. It's started. And now we can just connect to it. So let's do that. And voila, right? Like now we have a REPL going and it works exactly the same as any Clojure REPL. And nice thing with Babashka is that it has a lot of stuff built in. So you have stuff like HTTP clients, shell interaction. It actually uses Selmer for there's like a macro for splicing commands and stuff. And it's Selmer based, which was really neat because then we got to collaborate with Bergdun to make Selmer compile with Graal and just remove like any JVM dependencies from it. And anyways, yeah, so once like I do all my development generally by first thing I do, right, like is start the REPL app, whether it's like real app, Babashka prompt or whatever, and develop stuff interactively. And what I'll try to do is, either get some data from a service if I'm working with a service or a database or something, see what it looks like and start massaging and just kind of like building iteratively. And I like to, write a function, test it, see it's doing what I want, then write the next function, write the next function. And it's almost kind of like a test-driven development, but faster. Because, right, like you don't really need to jump around and make tests. I like to do stuff like this, like I'll make a comment namespace for, or not namespace, comment block in the namespace. And then, right, like if I have like def and I don't know, like foo, x, y, right, Like, oh, okay, we got, like we got foo. What does foo do, right? And then I'll often just like leave it in that comment block. And the reason I put in the comment block is because sometimes, right, like when you check stuff in, you inadvertently like forget and like leave some stuff that you do for development. So if you always start with a comment block, then you kind of like, even if you forget to check it in, it's not as big of a deal. Sometimes it's also useful, I find, to leave a sort of documentation. Because often if you're working with a real system, like you'll need to get, I don't know, like a database connection or stuff, and you need to kind of like do a bit of boilerplate to do it. So I'll leave like some examples at the bottom of the namespace for testing it, and then when I come back to it, it's like, oh, okay, let's run these things. Like often, right, like would be like get a user from a database or like do like a query or something. So I really like doing that sort of thing because then it's also useful like when you work on the team because then you just scroll down and there's a few examples of what to do. Key part is like keeping that up to date because sometimes what happens is you leave some examples, right? You forget about them, but that's just kind of like same thing, right? Like with documentation tasks and so on. You just have to be proactive. But yeah, like my process it tends to be is start small, build iteratively, try to solve a problem in a REPL before I get to tests. And often, right, like what I get in this comment block can typically be translated into tests fairly mechanically, right? Because you just copy paste and like add some like mocks or whatever you need to do to make it into a real test. But what I don't like doing is like the reason I don't like doing tests first is because you often don't really know what a good solution is going to be, like what your API is going to look like, how you want to approach a problem. And I find the best way to figure it out is often to just brute force the problem. Like just, you know what your input is going to look like, you know what you want to output, just solve it in the dumbest way possible. And, like don't worry about making it clean or whatever, right? Just like get through the problem. And once you're done, then try to break it up, refactor, clean it up, and then do the test, right? Like at the end. And I find very like my solution is often a throwaway solution. I'll kind of very like by working through the problem, I get a better understanding of the problem. And once I have that understanding, it's usually easier to rewrite it in a clean way because now you're making less assumptions. And I find that's kind of like the biggest, I would say, mistake people make is to try to do too much design up front before you start writing code. Because you can get, right, like I think everyone's done it, especially like if you have a team and you just talk and talk and talk about how to solve a problem and all the what ifs you're going to have. And it's like, oh, are we going to do this? Are we going to do that? Is it going to perform well enough? Right. And you can spend like days on doing that. And like certain amount of understanding is good. But at some point you want to write sort of like an MVP, a dumb prototype, because it's going to make a lot of things concrete for you. And things that you could have been discussing for hours just kind of like fall out of that automatically. So I really do recommend doing that. Try to get a base understanding of what you're trying to do, and then try to implement it in like a really simple way. And I think right, like there's also kind of like a separation where there's this kind of like production quality code versus experimental code. And often people want to jump right into this production style code where you do, like error handling, right? Like logging and like set things up. But it's often good to just kind of work through the problem and use the REPL, since we're talking about right, like showing the REPL is to kind of like work with the REPL to figure out how this problem should be solved in the first place.
And I think this is an important piece where the Clojure REPL interactive development really shine, because you can quickly experiment, and this you can do this by the way with thinking. Yes, so it's quite natural. So that's interesting. So what that point when you start writing tests? So you experimenting a lot with these functions, playing with them. Yes. So when you decide that you should go and start writing tests?
Yeah, so I think like the point where I get to test is basically once I have all the functionality I wanted to have for a feature, and I've like tested out on this comment block I make. At that point, I'll take that and go right like at the tests for the thing.
Yeah, with our team, we discussed some crazy idea that why not just put test into the same file? Yes, why this, instead of comment block, it could be some magic like test block, which will disappear from the production build, but potentially tests can be collocated with the code. At least.
I actually think it's a good idea. Like, I don't know why we don't do it, right? There's no really good reason, because like one of the things I find is you want to make as few jumps as possible between namespaces, right? Like I find it's good to collocate code that's related, because when you read, you kind of like build up a context of what the code is doing in your head. And if you have to jump between different files, it kind of breaks that context, because now you look at one file, you kind of have to, right, like put it in your head, remember it, go read another file, then jump back to another file. And this is why I find like Java style development, for example, is very painful, because the language encourages you to make a lot of files. Everything becomes a class, right? And you have like each class in the file, and just like, and it's very easy to understand each individual line of Java, but it can be very difficult to understand the intent and what the overall code is doing. So you kind of like lose the forest for the trees in a sense. And yeah, and right, like from that perspective, putting tests together with the code means you know exactly where your tests are, and you also can, if you structure your tests well, you can sort of use them as a form of documentation for the code, right? Because you can provide examples of how the API works and what you're doing with it. Which leads me probably like to another topic is I find with tests, it's more valuable to test at the API layer, in my opinion, than to do individual tests. Like stuff like unit testing, I find provides little value. And it adds a lot of overhead, because anytime you change a small component, now you have to go change your tests for that component. But like my perspective on it is, as long as nobody dies, it doesn't matter how the sausage is made. Like you care about the end product. So if you're saying, like my API has this functionality, I like to treat tests as sort of a form of specification for that. If I give this input, I expect this output, right? Like this is what's defined, this is what's undefined. And as long as the API responds in the way I expect with defined inputs, that's all I care about, right? Like if I make changes internally, as long as I rerun the tests and they still produce the same output or expected output, then that's what I care about.
Yeah, I completely agree. There was a long discussion. I think it was a series of Hangouts calls between DHH, the creator of Ruby on Rails, and the father of test-driven development, Ken Beck, where they discussed unit tests versus functional tests. And I'm definitely on DHH side, at least for the business applications. So if you write first functional tests, so first of all, you have freedom to rewrite your implementation, because it's not in stone, yes, and you definitely will rewrite it multiple times. But this functional test is much more stable to changes, yes, so because you know the requirements, so how it should work. And do you have any special tricks how you shape the tests? Because do you try to run tests in the comment style way, like expression by expression when you're working, or how do you manage state in tests? Yes, because this is another important question. There's a more important question, how you manage state in the whole application, yes, but how you work with the state in a test.
I find that depends on the test. I guess, yeah, like I said, right, I like to focus tests on APIs. So for example, if usually I work with web apps, so I'll test around the HTTP layer and do it like root by root. So each root has its own set of tests, and you can like do like testing block and then like have tests for each.
And do you have some example of real tests from your open source projects?
Okay, yeah, like open source stuff, definitely. Yeah, let's go to GitHub. Let's see. Let's go to Selmer, because Selmer is pretty comprehensive, I think. And we can see, let's see. So let's do the core test here, right? So we have all the imports. Selmer, of course, doesn't really have any state to it, being a library. If you put state in your libraries, don't do that. And yeah, like we can see, right, like there's some helpers at the top. I think that's like pretty common. And then yeah, right. Like I go like by each piece of functionality. Like for example, right, like what happens if you remove a tag? What happens if you right like have filters? What happens for each kind of step? And basically the way this has grown is I had like an original set of tests for functionality Selmer had it first, and every time somebody submits a pull request or asks for a feature, I made sure we add a test against that specific feature, and that gets used basically as regression testing. So I think like you really learn to write good tests if you work with open source, because the nature of open source projects is you work on them occasionally, right? Like you do this initial spike of work on it to build the initial functionality, then you publish it, and then a few months later you come back to it, and somebody found a bug, or you want more functionality out of it, and now you don't really remember the code because you haven't touched it in months. And it's not realistic, right? Like to try to remember everything your code is doing. And then the tests really become your kind of guardrail to make sure, okay, I think I made a change. I think it makes sense. Let's run the tests. Okay, I didn't break anything good.
Yeah, as well for library, you have to have something working. Yes, if you're doing web application, you have some UI so you can click and play with it. But for the library, you need this point when you're touching your your code, and this is mostly tests. Yes, you may have some examples, but yeah, tests.
For sure, yeah. And it's also kind of like, again, right, like documentation. Like, I mean, for Selmer, I actually spent the time to write fairly decent documentation, I hope. But I find for a lot of Clojure libraries, that's what I end up doing, right? Like I go to the library and I go to the tests, like I'm extra tests to find stuff I need. So it's and I find like tests tend to be the most accurate form of documentation because they actually run.
Mm-hmm.
Like docs always have the problem of somebody forgets to update something and then it gets out of sync. And it's kind of hard to keep documentation along with XRs, especially like a non-trivial project. But yeah, as you can see, right, like there's probably actually more tests, like just lines of code for tests than actual source code in Selmer.
Mm-hmm. And
I
I
mean,
see it's quite huge file. Yes, so let's
yeah,
say you found the bug and you're working on a specific assert. So how do you run it? So you run the dev test for this specific piece, or you even run one expression in this test?
I tend to run like the full dev test, but I find like when I write the test, I'll often write it as a function first, or just use it in REPL to kind of like get the feel for it, and then just stick in dev test after I'm happy with what it's doing.
Because I catch myself that sometimes I'm working with tests on the expression level, like in command block, and sometimes we even do def instead of let to be able to do this, so you can like debug it like step by step.
Yeah, for sure. I find, yeah, like debugging story in Clojure is kind of interesting because like debuggers exist, but I find most people never use them. And part of it is that usually, yeah, like you said, right, like sticking the def or println will do the job. And I think like, right, like the reason it works in Clojure in particular is because you don't have a lot of state you're dealing with. So like when you get an error, right, like, or if you look at the lines, usually like problem is within a few lines of code from where you get the error from. Like it's rare that you need to kind of like trace through your app and figure out how you got there. I think that's kind of like, to me, is also a sign whether like a particular library or project, right, is structured well or not. If you find yourself to having to build up a lot of context, that means you have a lot of coupling. And that's basically a code smell, in my opinion. Like in general, you shouldn't need context to figure out what the code is doing. Like you may need some context to figure out, right, like an overall flow of data through the application. But if you're looking at a particular function, you should be able to tell, just based on inputs and outputs, what the function does. It's kind of like, right, like I think like of Clojure is sort of playing with Lego. Each function is a Lego block, and you can snap those Lego blocks to build complex things. But there are like small reusable blocks you can kind of think about independently and just snap them together to build bigger things. I find that tends to be like a structure for a namespace as well, right? Like if you look at the Selmer and let's say like the parser, we started out with small helpers, And then as we go, we get like bigger and bigger functions that assemble them. And towards the end of it, we're going to see the API level functions. And I find that this is pretty common for most Clojure projects, right? Like if you want to know what the library is doing, you just scroll to the bottom of the namespace and then you see what's happening. And it's also kind of like almost like enforced by the compiler too, right? Because you have to declare stuff before you use it. So it kind of like guides you towards the style where you can just like all your bigger functions live at the bottom and the smaller ones that you assemble live at the top. I've come to really appreciate it because sometimes I look at other languages like something like TypeScript and it's all over the place, right? Because there's no structure to it. So it's like sometimes like, oh, this thing is getting used. Where is it declared? Oh, it's declared below somewhere, or in another file or whatever. It's just like, again, it creates this mental overhead of assembling the flow of the program because the compiler doesn't force you to write it in a particular way. So sometimes those kind of like restrictions are actually pretty valuable.
But we're still reading code bottom up, yes. So if you reading code,
exactly.
you should read it bottom up.
Yeah. So it's like, if you're ever confused about like a Clojure file, just go to the bottom and read bottom to top, and you generally will get a good idea. Yeah, speaking of Babashka usage, that's a macro that makes it nice and easy to use in Babashka. Let's see, we should actually be able to do it. Speaking of using the REPL. Yep. And let's try to or yeah, let's refer it. That's the bad thing since we're in there. Oops. Yeah, I guess I can jump into, let's see. Okay, and I forget how the syntax works actually.
It's your
Oh, it's from local environment. Okay. So hello and oh, that's a mistake. I said oops. So as we can see, it underlines when you do the wrong thing. Yeah, there we go. Right. So yeah, so actually another thing like we didn't talk about, but like using the editor, I find like a lot of people tend to use a lot of structural editing commands. But I've come to realize you can get by with simply using extend and shrink selection. Like those are the two most useful commands in a structural editor, in my opinion. Because what I often do, right? Like say I want to navigate to other expression, right? I can just select and go here. Or I select this and do, right, like, I don't know, like str. Right? And then you can just kind of build up like this. So you don't really need a separate command to jump to the outer expression, right? If you want to like move something in, select, move it here, right? So by remembering basically just two commands, how to expand or contract, you can do navigation, right? If I want to go to a left, I can go here, I can go here, right? It's using arrow keys and selecting up and down can get you a lot. And now you don't have to remember a whole bunch of commands. So if you're starting out with Clojure, these are the two most important commands. So make sure you have your structural editor enabled. Like you never want to be managing parents by hand. That's an absolute no-no in my opinion. And shockingly, I see a lot of people do it. Even people who've been using Clojure for a while, they don't use structural editing. And sometimes you talk with people and they're like, oh, but it's weird and I like having that control. Just trust me, right? Like you spend a few days with it, doing it day to day, you will never go back. Because once you start using structural editing and you just, like let go and let the editor manage the parents for you, you start thinking about it in a different way. You're not thinking about like lines of code. You're really thinking about little building blocks, right? Like every time you have an expression, you think about it as a little building block you have. And you just kind of like assemble them, right? Like again, like that whole Lego analogy.
Yeah, let's demonstrate. Let's decide. Let's say we want to wrap it into some if expression. Yes. What exact actions you will do?
So yeah, let's say like we're doing it, right? Like we have this,
Yeah.
and then if equals well, a, right? Like a otherwise, right? So that's kind of like how I would run through it. And then like say we need to change it to a cond, right?
Mm-hmm.
Go for cond. And there was obviously like fancier ways to do it, right? Because there was like a lot of things you can do that jump around. But I find like, right, like I find Clojure is very concise. And the absolute amount of time you spend typing stuff is so low that like optimizing for even faster typing, I find is not really valuable in my experience. And the advantage of using like a fairly small set of key bindings is it's very easy to move between different editors or like between different machines, because then you just set up like 3 or 4 key bindings and you're ready to go. And yeah, like it's like I find like really like the big thing that we want to solve is not having to manage parens, to have the editor manage the expressions for us. And the other thing we want to solve is to be able to navigate quickly inside, outside expressions and reparent them easily. And like once you have those 2 things, I think that that's the biggest value of structural editing. Like I don't know, like what's your experience with that?
Yeah, I'm VI guy, so I like all this slurp and other stuff, but it definitely, yeah, the structural editing is an important piece of Clojure. I'm using some advanced stuff, some macros to convert to arrow macro or stuff like this, but not all of them. Yeah, I just have a collection like top 20 operations I usually do.
Yeah, I think that's basically how everybody kind of does it, right? Like you saw like a subset of commands that you use day to day, and then you're just like, yep, that's what I need. Because yeah, like some of my friends use Emacs and they can do like pure magic with transformations.
How do you navigate between test and the code?
I'm usually very ghetto, so I'll either use kind of like Alt Shift P, like to look for it. I know. Oh, like this one won't even do it. Don't have it set up yet. But yeah, often like it's just gonna be the tree on the side.
Mm-hmm. So there is no hotkey to jump between code and source and tech and
No, I do not have one.
mm-hmm. Because I found it's quite easy. So and other stuff that do you have hotkey to run tests while you are in source file? This
I
specific.
usually just do it from REPL, right? Like I do like run
Mm-hmm.
tests.
Mm-hmm. So
Like
you
I'll set the namespace to the test namespace and just go from there.
Because in Cider, in Emacs, you may run the test which is related to this source file, and it's very handy. So you jump to test, you write the assertions, then you jump to the source, you're writing and running with the hotkeys the tests, which is shown, the status is shown on the bottom, so you don't switch back to the test. So you're just running and running it until it's green.
There is a project actually I've used before called I believe it got updated for depths as well now. But the idea, yeah, so you can use it. Where is it? Yeah, with depths. And the idea is you just run it on the terminal, and it watches for changes and just kind of like runs a test. If you're on the Mac, it can actually like hook into notification systems, and you can like, oh, you screwed up. So that's a handy way. But I find like, yeah, like what I was saying earlier is the way I tend to develop is tests happen at the very end, usually before I try to commit. So I'll kind of like do all the development in the REPL, just stay in that namespace, use a comment block to interact with it. And then if it's an application, right, I'll actually like try it through the app and make sure things seem to work. And then the very last thing, just run the tests, make sure they work, and if something's broken, then I can like fix it there. But yeah, I find like I don't run tests often. It's really like my final guardrail for making sure nothing's already broken. And I try.
Yeah.
I was gonna say like I try to keep code like as isolated as possible so that I find again, right, like to me, like one takeaway I've had, and especially working with a dynamic language like Clojure, is really minimizing working context, right? So like the way you want to structure things is that you can just look at one namespace and stay in that namespace ideally and not having to think about anything else if you make changes there. Like, max like 2-3 hoops. So for example, like sometimes if it's a web application, I'll have the endpoints and the roots, and then the handlers, and then some maybe database queries. And like at most, it'll be like 3 namespaces. I find like usually like the reason I would even like separate the roots from the handlers is just to kind of keep the code more concise. Because sometimes you just want to see like all the roots together. And then you just have to write like the handler functions for each one. And then queries often, right, like it makes sense to just again like put it straight in your actual handler and just see everything together if it's not big. I also find like one of the mistakes people make is trying to reuse code too aggressively. So if I have an application, if it's a web app with 2 endpoints that query the database, and maybe they have a similar query, like let's say we're querying users and we're querying users in a different context. There tends to be a tendency to try to write a function that's gonna abstract that, right? And then you have some sort of like an if condition when you get, right, like your data in, like, let's say you have, I don't know, like, right, like if you have something like def user, and then maybe we'll have like keys, right? And it could be like user ID or email, right? And I'd be like, well, if user ID, then, do a query, JDBC query by user, right? Select, start, whatever, right? Like where user ID. And see, like some of the stuff VS Code does sometimes where it's just like felt it needed a column there. But yeah, right, like, and you do, right, otherwise, do by whatever. Do a query by email, and then it could grow, right? And eventually you have some business logic here. And right, like here, it's like really simple, and you might be like really happy that now you can have one function you can call and pass it the same data structure. But then over time, this function could grow and start calling other functions, and then becomes complex. And then what happens is a few months later, either somebody else who's never seen the code, or you, and at that point, you might as well be somebody else who has never seen the code because you forgot what it was doing originally. You come in, and you need to make a change, and you make a change, and it works for the use case you wanted to change. But now you're not sure if you broke the other use case.
Yeah.
Right? Because you forget like what all the intricate details of this function were and why it's doing all these conditions. And now you're screwed, right? Because you don't really know if you introduced a bug or not. And like if you're lucky, you have a test, it'll catch it. But a lot of time, right, like this thing becomes fractal. Like it's impossible to test every use case. But now, if you take a step back and instead of doing this, we just have 2 separate functions, get user by email, and right, we'll do this, and then get user by user ID and do this. And again, you can see like my structuralize its own ghetto approach. Now there is no problem, right? Because now you have just a single function doing a single thing. And so I think like going back to a bigger picture, if you have your routing, think of each route as a microservice. It's its own world, right? Like it depends on the inputs the route receives. It does some business logic, does some queries from your data store or remote services, aggregates them and produces a response. And that's its own world. And if you do it that way, it becomes much easier to work with your application because now you need to go make a change, you find the route that you want to change, and you're done.
Yeah, let's
And
play this game. So can you kind of let's say you're writing the web application from scratch. How would you structure your project? Let's say we have like user
okay, yeah,
management and something else. So
let's
what
do this.
files, yeah, would you create? So I
So
yeah. Okay.
this problem I've been solving for a while now, and the latest iteration is Kit. So just to give like a bit of introduction to this thing, it's a lot of it is based on Luminous, but actually a friend of mine, Nikolai, he worked with Luminous, and he found there was just like a few things he didn't like about Luminous. And one of the things he didn't like about Luminous, there was a little two batteries included. When you
Mhm.
made a project, it would add like HTTP routes, it would add pages, it would do all those things. And the idea behind that was to make things as easy as possible, right? Like if you don't know anything about Clojure, run a command, you have kind of like a full web app, and now you can do stuff with it. What he wanted is like he worked primarily with backend services, and he didn't really need all this junk. So from him, it was a net negative. You build, you make a new project, and now you spend some time deleting stuff from the project before you use it. So originally, he just wanted to make something a bit smaller. And then we talked a little bit, and we were like, well, what would be really cool is if you could start with something small and then add stuff to it as you go, right? And that's the biggest limitation in Luminous is that unless you use a particular flag when you make a template, you kind of have to manually add all the boilerplate. We're like, what if you could just add the boilerplate, programmatically? Like we can analyze Clojure files, and now there's a really nice library called Rewrite CLJ. And using that, you can just write like as long as you kind of like know the structure of the project and people don't change it, you can add stuff to it. So let's take a look at this. So we'll make a new project and hopefully it will work. Curse of Life demos and all that. So let's see. Myself. And we'll take a look at the anatomy of this once something happens. We love Clojure startup times.
Mhm.
There we go. So, actually, what? We can just do it here. It's probably just as easy. Okay. So let's take a look at this project. So the way I like to structure stuff is obviously there's going to be, so the other big change is Luminous uses lane engine. We decided to go with depths, mainly because it's just what everybody uses nowadays. There's no point fighting the current. I also think like initially when depths came out, it just wasn't really sufficient. Because I think like the thing with lane engine, it's again, right? It's the whole simple versus easy.
Yeah.
Lane engine is easy. It does the things you really want to do with a typical project, right? Like it lets you start the REPL, run tests, compile an Uber jar, and those are really the three things you do with like 90% of projects, and manages dependencies for you. And you can, and I've often seen the main critique of lane engine is people say it's like, oh, but it gets like really complicated when you start adding profiles and you can, put like macros in your project still. And I'm like, but this is a self-inflicted problem. Nobody is forcing you to make a really complex project CLJ file. And in fact, right, like you could just write scripts outside of project CLJ if you need to do complex things. So like I've always kept project files really basic and simple. And I've never really had those problems people talk about. It just, it just works. But now that we have depths, we can do a lot of similar stuff with depths. But it is like, this looks very similar to a project file. We kind of have aliases instead of profiles, but similar stuff. There is a separate build file, which I actually do like because this is a program, right? And you can just do whatever you want with it. I would say this is actually one place, and like once especially the tools build thing appeared, to me, that's where like depths reached parity or official tooling reached parity with lane. Because before you basically had to make your own script to do stuff. Now there's kind of, like, oh, you can make an Uber jar. But the one thing Kit adds on top of it is a Babashka script. And this basically gets you back to lane world where you don't have to memorize, right, like all the little flags. And I really think this, to me, is a problem for beginners. And I'm saying this because I've worked with beginners a lot, and I know it's a problem for beginners. Because like memorizing like what dash T means, what dash M means, right? Like all those commands, it's kind of overwhelming. And I think like we don't really appreciate it in the Clojure community that people starting out aren't really going to care to figure this out. Because Clojure as a language is competing with all the other languages, many of them much more popular. People only have so much time in their day. So what they're going to do is, somebody's going to tell them that, hey, you should try Clojure. It's really cool. It's really fun. If they spend, their first couple hours trying to figure out which flag to pass to start a REPL, they're not going to start a REPL, right? And they're probably just going to move on to Elixir or whatever else, right? Like the new hotnesses. That's just the reality, right? And it's not because people are stupid or ignorant or whatever, right? It's not their fault. It's just you're trying to promote a technology that's niche, that very few people are familiar with. And this technology is competing with all the mainstream technologies, plus all the other niche technologies people are going to try. And they have to have a good experience out of the box to really believe you that it's a good technology. And I suspect this is why, right? Like if you talk to people, most people who stick with Clojure, they stick to it because they ended up using it at work and they had somebody mentoring them. Mm-hmm. And that person already had a lot of experience using Clojure and they developed the workflows they like, and they kind of imparted that workflow on this new person. And becomes this oral tradition of how, to structure Clojure applications, how to use build tooling and all that. And that's unfortunate, right? Because it's very limiting for us, I think, that we don't make it accessible and we don't try to lower the barrier as much. And I mean, that has been an ongoing discussion, I think, in Clojure world, like for a decade now. Like stuff like, right, like error messages. Right? That's like everybody's favorite topic. That, like, why are those error messages so hard? There's no real reason they should be so hard. And yeah, so anyways, going back to Kit, Kit tries to kind of make your life easier and just has BB tasks, and if you have a Babashka install, you just do BB run, BB end REPL, and effectively it works like Lane, but now you also have a bit more flexibility than Lane, which is nice. Then I want to point out environments. So one of the big things for me of working with a REPL is using the user namespace. And I feel like that's, again, one of those things that's kind of underappreciated. Some people know about it, some people don't, but basically what it is, it's a namespace is going to get loaded in your REPL. It's always accessible as user, and you can dump stuff in here. And this is a really good spot to dump tests and stuff, right? So for example, like out of the box, right, there was like go and reset. Because if I'm in the REPL and I want to run this, and like in real app, I'll dump a lot of stuff. Like for example, say I want to get a database connection. I'll put this thing here that lets me get a database connection. I have like user con, get the connection and go. So actually we can, let's do this. Let's start the app. So we're in a guest book. This should work in theory. But yeah, so basically this would be my workflow. So I made a web application. I'll connect the REPL to it before I start doing anything. And while it starts, let's take a look at a bit more stuff. So yeah, user namespace, I highly encourage using it to kind of define common things you do in a REPL. And just like make functions, put some, right, like calls in here, whatever. It's always available. It's in a separate, the way I have structured it in Kit is it's in a separate env, which doesn't get included when the app compiles. So it just gets entirely excluded from the project. And then there's prod, which doesn't really do anything right now, but you can add some defaults that you want for prod that you won't have necessarily in dev. I find like in most cases, you don't even really need it, but where it can be handy is if you want to, I personally prefer to use a class pass to decide what's going to be included and what not, instead of using a runtime flag. So often, right, as an alternative to this, you'll see like, you'll have like, if development, do this stuff, if prod, do this other stuff. And then you run it, right, and you use the flag to select. And I find what often happens is your environment doesn't have the right flag, and then your app starts up in a bad mode, and then weird stuff can happen. If you just don't include the dev code in your project when you build it, you avoid the problem entirely. So that's personally why I like this. But yeah, the alternative is to just use flags at runtime. Then we have resources. So the way Git's structured is Git uses integrant, and it uses arrow. And one cute thing about integrant and arrow is that they're compatible. So you can use a single config file that has all your configuration, all the environment, and it declares all your resources. So this becomes kind of a declarative way to say what the structure of the application is, which I think is really neat. Because otherwise, right, like we often have like a config file, and then we read the configuration, instantiate things. But here it's basically all together. And this also handles stuff like testing, because you can define something as being a test or not. And then it's just going to get included or excluded during runtime. So this happens, I think, in here. Yeah, so we pref and we say profile dev, and depending on the profile, you can include or exclude stuff in here, which is really nice. So then you can merge your test and dev and prod configs all in one place. And then again, you can see like everything that's happening in a single place. So now that we have this thing, and we have this thing, we should be able to connect to it. Obsidian, connecting. Oh, yeah, there we go, connect. So one of those things that Git does that I mentioned is allow you inject some stuff. So right now, if I do reset, it should start up. And if I go to localhost, there's nothing here, but I think there is like status. Oh, let's take a look at the roots. Sorry, resources, web, roots, API, and somewhere here, oh, it's /else, sorry. So let's try this. Oh, is it API health, possibly? Let's see. I always forget how my own projects work. That's why I have the REPL. So yeah, so we have this, right? And if you take a look at the roots, we basically have, oh, I'm not in the roots. Sorry, here, we're going to drag it over. So basically, there is a very minimum thing that sets up your API, adds some common middleware, and initializes it. And this is basically the entry point for application. So if you're not familiar with Integrant, it's kind of this dependency injection framework that does inversion of control. And the way you end up, like the entry point to your application becomes your system file. So when you are, oops, resources, sorry. Somewhere I have my, why am I here? Okay, so yeah, so basically we declare roots, and that's going to be the entry point, and whatever resources you want to pass in, you just say roots, depends on that. And you can get fancy with it, but again, like I recommend just keeping it simple, because usually you're not gonna have a lot of necessary complexity in your dependencies. I find in 90% of cases, the only actual dependency you have is your configuration, because configuration has to be loaded from the environment and has to be passed around everywhere. But it's actually rare that you have different resources that are interdependent, right? Like if you have a database, it talks to a database. If you have a queue, you talk to a queue. You have a HTTP endpoint, you talk to HTTP endpoint. It's right, like it's almost never a case that you have like an HTTP endpoint that depends on database being started to be available or something. And so yeah, so this is basically it. This is kind of like your effectively your main that's going to be entered, and then if you're getting an HTTP call, there is a util that just is a helper for parsing data from Reddit, and then there is a handlers, and that's kind of like what we talked about before too. Mm-hmm. This starts up the actual HTTP server and inject the roots into it. Potentially, like honestly, like roots could be combined, like this thing could be combined just straight into a handler and just do everything from the handler. It's always tricky to say, like what the right level of separation is in practice. Okay, and then we have the config. Again, just reads the config. And the core is the actual main for the application that does the Java main and starts the app, stops the apps, shuts down the engine, does all the cleanup for you. So that's basically it, right? Like, so it's very, very tiny, nothing too fancy happening. And then if you go back to user, so now we can do this, or get some modules, I believe is the function. So what this will do is create a modules folder that gets cloned directly from place from the modules folder here. And you can see we built a whole bunch of different modules, right? So for example, here's an HTML module. And the way it works is we're saying, here's our assets. So that looks kind of like a laying template. And these assets will be read. Anything that's runtime is going to be injected into them. And then we're going to get generated as files. And then we have injections. And injections work on your existing files. So here we update the system even because we want to add a new root for pages. We update depth even to add Selmer and bring session. And we update the core to add the namespace so it actually gets loaded. Right? So now let's take a look at that. So we can do git list modules. And here's what we've got. So let's do git install module git HTML. All right, so let's do user. Oh, yeah, let's do reset because we're here. And as you'll recall, before we couldn't go to the home page. And now we can. We have HTML plugged in, right? So this is a big improvement over Luminous already, because now you want to add like closure script. You just add closure script to your app. And the neat part is modules can declare dependencies. So this one says it needs to get HTML, so you don't have to know to install HTML before you install closure script. And because modules are namespace, you can kind of make your own namespace for your own modules. So basically, a stack of modules, it has to be done within the same namespace because you have to make some assumptions. For example, here we're making an assumption that HTML is served by Selmer. If you do it with Hiccup, then you can get some different assumptions there. But the cool part is this democratizes the process because previously when we used Luminous, if you want a new feature in Luminous, you had to go to repo, make an issue, convince me that I want to maintain that feature, and then you have to do some work. Now you can make your own modules repo, stick your modules in there, and then if you go to here, or sorry, there is a kit hidden file. And this declares, right, like the project namespace and all the stuff that gets used for injections. So speaking of that, let's take a look at our fun stuff. So in our resources now, we have HTML, we have public, right? So this stuff got generated. And then in pages, we have layout. And basically to synthesize the correct namespace, that's what this is getting used for. And then we have the modules. And I have my repo and the tag and the name. And you can add more. So if you want to make your own Git module, right, you just go take a look at one of those ones. They're pretty simple. Make your own module, and voila, now you have your own thing you can add on to Git. And everybody can do their own, right? You can make it private, public, whatever you want. So I think this actually, for me personally, made my life a lot easier.
So that looks like Luminous evolution, yes. To be
for sure.
Modular. But it still use some conventions, yes. So it
in fact, I would argue this relies more on conventions because the modules expect a certain structure. If you change, if you move things around, now you're on your own. So you kind of have to keep at least a few things like core namespace, roots, and depths. but yeah, but now, right, like you can have this like very small core, as you saw, right, that literally has two files. There's like core namespace and root namespace, and that's it. And like I think like, you can tell, right, like this couple lines of code. So your initial project becomes very, very tiny. Now you can take it like in any direction you want. But also, right, like you can get, oh, I just want to add closure script to the whole thing, run, install kids LGS, and now you have closure script. I think we can probably do it, in fact. What's this? Git install. There we go. We'll probably have to restart everything for this one. But yeah, now we have CLGS stuff. And let's install a database module. Because then we can play around. Well, I don't know if you want to. List modules, but let's see. So, module. Oh. And I think we can say SQLite. There we go. So yeah, so that's the other thing, feature of modules that we have is module can have profiles. If you have something like SQL, you might have like, like Postgres, SQLite, whatever you want. Let's bounce our project because I'm pretty sure this plan. Well, actually, let me take a look. We may not have to because I think, yeah, we have watch tabs, which may load things for us automatically even. Let's see. So we should have something with a database now, somewhere. I forget where, maybe not. Oh, you know what? We probably just add the thing.
Yeah, I see migrations.
Yep. Okay, so let's do this. Sorry, did you see the? Oh, yeah. Why don't we take a look? The beauty of this is you can always tell what the module does. Okay, yeah. So we have migrations folder with the queries, and then we add the connection. So yeah, let me show actually the thing I wanted to show. And the reason we went down this path is if you're in the REPL here, we can create a system, right? So we can say, where do we have the system actually? Somewhere in integrant, it does give you state.
IG start system.
No, they have those things, right? So you have config system and prepare. So let's try state system and see what that looks like. Yeah. So that's a map of all the crazy stuff that we have, right? Let's do another reset. Now it's chunkier. And let's take a look at this. So we can say keys from the system, and we can see all the things we have, right? And let's grab a connection, for example. So that's kind of like our data source, right? And this is an example of what I would do in the REPL, right? So I could do defn con and then do this, right? Because I know I'm going to be doing this a lot. And then whatever namespace I'm in, I can say user con, get access to connection, and now I can start working with that, right? So if you go say, well, let's go to controllers, doesn't really matter. Sure.
Can you tell a little bit more about the folder structure? So we have a controllers, so that's intended to be like the endpoints, yes, REST endpoints defined.
Yeah. So basically we separate the roots here from the handlers. Maybe handlers would be a better name, actually. But yeah, so basically we have, right, like somewhere here we'll...
But the rest of the logic is going to live in controllers, yes?
Yeah, exactly. So we just have, right, like this a get. So we define the structure of the roots in here, and then we delegate to here and we do something there. So yeah,
For
so if you
example,
want,
if we're doing like users CRUD, so we will have users.clg and controllers or namespace users, how you organize it. So let's say you have few entities and endpoints.
I don't tend to organize. Like I said, like right, like I tend to actually organize based on the endpoint entirely. So I would like have a controller that says the action you want to take. Like for example, like I wanna, I don't know, like register user, right? So it would be like something.
So you will organize around the scenario, yes, some kind of scenario.
Exactly. Exactly. So if you do this, right, we could have, or I always forget right the syntax, to be honest. I think this will work, or we can do this actually. This will be better. And let's say we want to have like API, oh, type, and under API, let's say we have register. And then here, right, like I get like a post, and then the post handler. And this would go to like, I probably, yeah, like have a you maybe, I don't know, like it depends, right? Like I'll honestly, like what I would do first, I would just write the handler here. I have like a fan request, do something with that. And then if it gets big enough, right, like pull it out, like figure out namespace as I go. So I always tend to go like from small to bigger. And like that's exactly like kind of decision I will defer, right? Like how should we name a user's namespace? Should we have like a user's namespace? Should we have like a registration namespace? You can spend a lot of time on these decisions, right? And I think like right, like what becomes easier, it's like if you only have like a single root, who cares? Put it there, right? Like you get 2, 3 roots, you start seeing structure. So I find like looking at your code and then trying to figure out what things are related meaningfully is better than trying to figure out what's going to be related before you actually have those things. Because your assumptions often get invalidated. Whereas when you have a concrete code, you know what it's doing, and you also know kind of like what's bothering you about the code. I find right, like, and maybe that comes also from experience, and might be harder to do if you're junior. But I find once you've written enough code in a particular language, you can kind of look at that and get a sense of how you want to refactor it and what would make it easier to read. So that's again the benefit of just deferring any sort of code organization till you actually.
But usually you put multiple handlers into one namespace, which are coupled by some logic, yes?
Yeah. So like maybe like right, like we have right now, what do we have? Controllers. I might even have just like right, like a controller CLJ instead, and just put everything in controller CLJ. Okay. I think like we structured Kit just to be sort of quote unquote proper, beginner friendly. Not necessarily how it structures the practices.
But the controller's name looks like comes from Rails, yes?
I think so, yeah. We can get Nick next episode maybe to talk about that because he structured a bit of this as well. And he might have deeper insight, but yeah, I think so. And yeah, but let's add a new controller. Why don't we? So let's find out. Let's just do a response. Okay. And okay. Do we have a response? We may not. What was the?
I usually just send hash map.
I find I forget all the different codes. I just like the semantic, but yeah, you can just do that. Let's try this. User. All right. It's not user. Unfortunately, I don't have it aliased. Okay, so that's one of those things I would actually do right now. So right now, reset comes from integrant REPL, and I'm too lazy to type integrant REPL every time. So reset and do that. Oops. Oh no. Are you sure?
I think you shadow.
Oh yes, you're right. You're right. I don't want that. Okay.
You can say do.
Yeah, because it's there. We go. Okay, we'll have a reset REPL and stuff. And now, right, like it doesn't matter what namespace I'm in. Yeah, back in here.
I've seen some guys assign this stuff to hotkeys, so they making IDE
Oh
code
yeah.
stuff, and then you can just press
Yeah.
Control R or something like this to
Try to
run.
be too helpful.
Yeah.
Yeah, no, like it's the kind of stuff you get like with Emacs, right? There we go. Thank you. And now we theoretically have API register, but I register. Oh, it has to be post, doesn't it?
We define just post. Yes, so we need.
Because I'm lazy. Oh, we didn't define it correctly because is our health still working?
API.
Oh, you know what? This is where the fun of Reset begins.
Mm-hmm.
Nope. What about health? Does health work? Investigation. Nope, completely broken. Okay. What doesn't it like?
So is there a function to see all the APIs which I do?
There may be.
So,
when it works, you can get the Swagger doc at some point.
Mm-hmm. You probably can generate the Swagger, yes, on fly. So
yeah, no, it can. It's actually hooked up, but right now,
let's see the Swagger.
Yeah, I might have completely broken the whole thing.
Like swagger.json, yes. So let's see. Yeah, the Swagger. If you call swagger.json, it should return all the.
It should give us something, yeah. But I think like I may have to move this up.
Mm-hmm.
Let's try this way. Embarrassingly, I still get confused by structure rates up.
Yeah, you can use our library, which is called roadmap. Have you seen it?
Oh no, I have not.
Yeah, just Google road.
All right, this still works.
It's much more logical. I think Reddit was done because the this original idea was pedestal, so using vectors, and we go with the maps for our routing definition.
Okay, I find like Reddit is okay to read. It can be a bit tricky to structure.
Mm-hmm.
Okay, so we sort of have, but now it's we got to do a bit more dense. This might work. Nope.
Why don't we see it in the Swagger? I don't know. So if we define this endpoint, so we should see it in the Swagger file.
But we can't see the Swagger file.
So we can call. Okay.
Let me see it because okay, let's look back a bit.
Maybe let's go and see this. Should it be prefixed with this? I mean, should we prefix with a slash all the routers, or
you should, but because it's all within one global route,
it's kind of, I think they just concatenate, yes, what they see.
I believe so. So
yeah.
Oh wait, is there, you know what, there may be a default here. Yeah, the base. Oh, that's why, because we're doing base pass with all the other stuff. So we don't want this here.
Yeah, I think this
might actually work.
This empty string was a problem here.
Oh, maybe not. Maybe there was no problem. Okay, let's come back to this because it's not ultimately that important. But what we can do, let's go take a look at their like health here, for example. Let's say we wanted to get like a database connection, right? So we could go to user, we can define connection from a system, and then we can start doing stuff. We can say, closure, Java. Oh, it's JDBC next, isn't it?
Mm-hmm.
But I'm gonna cheat. I'm gonna go to the docs and take a look at what we did here. Yeah, so you know what, let's do this. Let's do this stuff. So we have queries, so we can go to resources. Oops, not here.
And to be honest, I don't like this style. So why you should put your SQL query in resources? Why it's not co-located with your code?
Yeah, like that. There's definitely a debate, for that. Like I find I like writing SQL as just SQL.
Mm-hmm. So that's like you have DBA, the guys who will go to this folder and update your SQL query. So
not usually.
What's the reason not just write it in a code?
I find I usually write like the way I work with the queries too, right? Like I kind of use like one of those DB tools as a REPL tool for SQL, where I'll go to a tool that connects to the database, write the queries there, play with them, then copy paste them here and parameterize them. That tends to be my approach. But I mean, yeah, like right, if you just use like JDBC Next or something like straight from,
yeah.
I mean, I don't think there was anything wrong with that.
Yeah, we like much more the Honey SQL, which is kind of.
You're using that at work. I'm a bit ambivalent about Honey SQL because I find on one hand it's structured, but on the other hand it's not exactly one-to-one with SQL. And you often end up trying to like play with it in REPL to see how to produce something you want if it's non-trivial query, right? Like once you get joins, like get in or whatever, right? Like you start getting like, and that's what happens a lot. Like when we do stuff at work, you spend a lot of time playing with Honey SQL to make sure it's generating the SQL you actually want. And I don't find I find it's very rare that you actually compose queries. So that's why I'm like, just give queries and make it dumb. But different approaches. I don't think one is wrong, one is right. It's just preferences. I think that's actually like another thing to talk about is that so much tends to come down to personal preferences. And I find like what's really important when you work in a particular team is to really get a pulse for how people on the team want to work.
Yeah.
Right? And even like down to the question of what language to use, right? Like whether you want to use Clojure or not, really kind of comes down if people on the team are receptive to using Clojure. Because I've seen projects where people try to, like one person really likes working with Clojure and they try to get the rest of the team to use it. Everybody hates it, everybody's miserable. Like the person who likes Clojure is miserable because nobody else sees what they see. Everybody else is miserable because they have forced to use a spirit language they don't like. And everybody's having a bad time, right? But if everybody is kind of like on the same page that, yeah, that's kind of like the way we like to write code, it's going to be a lot better, right? And once you get within a language, right, like what libraries you use, how you structure the application, so on, it's really important to have those discussions as a team. Right? And talk and find this like lowest common denominator of that makes everybody at least comfortable. Right? You don't want people writing code that other people can't understand. You don't want to write them in a style that they find uncomfortable for them and that they struggle with. And this is I also find why pairing is really important. Like, or at least like at my company, we do a lot of pairing. And it achieves two things, right? Like one is you have at least two people who know how a particular piece of code works, which is always valuable. I find surprisingly, well, maybe not surprisingly, but initial reaction is, oh, now you have two people working on one problem, right? Like you could have like be solving two problems. It goes a lot faster. When you pair with somebody, and the reason is that a lot of time when you're working alone, you're not sure how to do something. right? You might be like, oh, should I do it this way? Should I do it that way? Like think of something. When you have a second person, they just go, it's like, okay, let's do it this way. You can get past that. And you
Yeah.
can, I find your velocity goes a lot faster because you're not questioning
Mhm.
yourself all the time. As soon as you have like somebody else to bounce ideas off, you have a lot more confidence and you're a lot happier, right? And I find quality control, right? Because you have two people looking at code, you catch bugs a lot quicker than you do individually. And by the time you get to testing, like your code tends to work pretty well. So your tests can be like a lot smoother experience.
Yeah,
So I've become like a huge fan of pairing.
yeah, I'm completely agree. So we're doing almost full-time pair programming for more than like 8 years or 10 years. So we as well experienced pair programmers. Yeah, we usually say like this. So if people working one by one, they eventually stuck with some task which may be too boring or too complicated for one person. Yes. As well, when you're working alone, so you're kind of doing compromises. Yes. And in pair, you don't do such compromises. Yes. As well, in pair, you can quickly unstuck, so you can decide, let's do it later. Yes, make decision later. Yes, let's move forward. As well,
Also,
eventually somebody doing some complicated task, and then the rest of the team is awaiting the results, so they starting forcing this guy whenever, and it's getting worse and worse. In pair, this responsibility, yes, and ownership is shared, yes, and we sometimes swap pairs, yeah. So you have like 3-4 people who is responsible for this code, and that's much nicer, yes. And you can easily go to vacation. You will be.
I completely agree. Yeah, and that's a really good point too, right? Because like when you're doing like stand-ups and stuff, if you have like two people working, then most people say it's like, look,
Mhm.
this is like where we're at. Here's how it's going. It's a lot easier to defend, like like if you need more time or something.
And how do
Nice.
you usually do your pair programming? So you're just doing Zoom call, or I don't know.
Yeah, yeah. We share over Zoom, and then one person drives, and then you can like
Mhm.
try to swap around.
So the last year we switched to Discord, and it's quite
Oh,
nice
really?
stuff because yeah, you see the rooms where the people are working like pairs, and then you can walk through it. So eh, you can come into some room, discuss something, move forward. So in this COVID time, there's a feeling that you are in office. Yes, so the people around. So Discord is nice. So I would recommend. Yeah, I recommend to try it.
Yeah. No, I've used Discord before. It's actually pretty nice. I find even Slack nowadays, like we sometimes use Slack at work because they have the new, what's it like, not Hangout,
Mhm.
what do they call it? I forget what the term is.
Yeah, yeah.
But anyways, yeah, right. Like it's kind of like a very quick way, like because we use Slack for general communication.
Mhm.
And huddle, that's the term. Yeah.
Mhm.
And you just you start a huddle, invite somebody, and you can share screen and get like really nice tools for underlining things. And so Slack has actually a nice feature that multiple people can share screens at the same time.
Yeah. The Discord can do the same. Yeah.
Okay, yeah, that's right. That's right. So Zoom is kind of like the most limited, probably.
Mhm.
But I find Zoom is just so reliable.
Yeah.
That's but yeah, I think that's basically it. Oh yeah, the thing I was gonna say, I mean, like this isn't gonna work because we don't have like any tables, but this is sort of how oh,
Sorry.
no worries.
Okay. I get back.
Okay, yeah. So I was gonna say like this is how I like to use that user namespace, right? Because like in the user we define our database here because we just grab it from the system.
Mhm.
And then I can just use it anywhere I want, right? So if I want to use it here, I just do user con, and then I have a connection I can do some stuff against that. I believe we should be able to run. So what we're doing is make Redis. I'll try to figure out how to make a database. Okay, okay. Um, let's take a look. because yeah, I should be able to
Mhm.
migrate. Oh, you know what? Let's try actually out some queries that might already be set up. Life may be easier than I imagine.
Yeah.
But you
I think
need
it could be the next step when you you load the dependencies, and probably all this documentation stuff should be in your REPL or your environment. So you just
yeah, for sure. I just like
yeah,
everything.
you're
I
just
think
running something, and yeah, it shows you documentation.
this may work. Oh, okay. Let's take a look. Yay. That's the problem with saving so many libraries. You forget how they work eventually. Okay. Yeah, it does make this color. Or is it just create? It might be create. I know there is a thing to create a migration. Yep.
Potentially, you should be able to run it from REPL. Yes. No?
There it is. Yeah. Okay. So let's do this. Absolutely. So let's go core here, and that should work. Yes. Yep. We're getting closer.
So we need just config.
Yeah. And config doesn't actually have to be anything in this case. Okay, so we have some migrations. Let's try at some of the migrations here. Oh, that's not a migration. Somewhere here. Yeah. Let's do this. Since it already works. So, ooh, exciting. SQL8. All right, because it would try to reload this, and there's no database for users. So one of the reasons to put in the comment block, in fact, let's follow my own advice. It also prevents weird stuff happening in the REPL. There we go. We may have a database now. I forget if it's hooked up by default. Oops. Let's find out. There we go. We have a database. So that's all you have to do basically to get migrations running, because migrations are already hooked up in the system file in here. And this will ensure they get run when the reset happens. And then again, right, like this could be useful stuff for user namespace. For example, at work, we set it up so you have like rollback and reset. So you just do, yeah, let me actually show you this. Different rollback. And then we'll do this for rollback. And we'll give it the con. And I think that's that. I'll take. Yeah. So why is it the zero arguments? Oh, actually, wait, that still doesn't make. Or is it being aliased? Is there a migratus in here? I don't believe so. So
yeah, I think you can require it.
Yeah. Let's... yeah. Yeah. What was the command for unload? NS. Is that unload? No.
You mean unload the whole namespace?
Yeah, because we need to unalias it and realias it.
So I usually define an empty namespace and eval the buffer and then remove this.
That would work too, probably. But let's see.
Yeah.
What was I complaining about? Let's start up, yeah. Although it might complain about everything else. That's a less fun part of the REPL development when you get in a bad state.
Yeah, but there's a remove namespace, yes, and then
Oh, maybe, yeah.
yeah, and you can maybe remove and then just load it again.
Yeah, okay, there we go. And now we should be good. So let's try doing a rollback. Oh, thanks. Callaway.
Mhm.
Very helpful. Oh, okay, we may have to do, I think. Yeah. Okay, so stores database in the BSD. Because we can't just use the connection directly. Oops. And oh, because we may have to do a reset first.
I think you need this system config, yes, here, no?
Yeah, but I have to reset the REPL first.
Mhm.
And now we should have a con. And now we should be able to do a rollback.
Yeah, I think this is important skill for the closure for REPL-driven development.
Yeah.
So you still have to keep in mind all the state and all these reloads, namespaces.
Oh,
it's not too hard, but you still have to understand how it works. Yeah.
Yeah, exactly. And I think that's what trips people up a lot. Okay, there we go. Right? There we got it. Oh, what does it have to look like? Wait.
Potentially, this is your config, yes? So
Exactly.
why you could not pass the whole config from Integrand? I think.
Oh, so
Yeah.
well, here we have the database, right?
Yeah.
I think we could probably do this. State, it's not config. Let's try that. And then we can get the.
Well, they are not aligned with migratus, yeah. So the migratus expecting in their own format, yes.
Yeah, actually, let's take a look at the migratus one. That's a good point because keys from. So we have stuff here, and let's see what we got under migrations. Okay, yeah, let's just pass that instead of trying to craft it. So now we can do. It is still not happy. Oh, let's grab it from a state.
Yeah, let's inspect what's in this key. Yeah, that one.
Let's use a story. Yeah. Eventually, it'll work.
Yeah, because it's not config; it's a system state. Yes, with the connection.
Exactly. Yeah. I was hoping it would work the same. There we go.
Yeah.
Okay, so now we can have like a rollback function, and then we can say migrate function. And this is something you're probably going to be using fairly often. Because then, right, like if you change any queries here or you change your migrations, you can just do rollback, migrate, and off it goes, right?
And do you use custom commands in VS Code?
I haven't set this one up. Like I played a bit with Joyride before. And Joyride lets you kind of like do this custom configs and aliases. But yeah, usually I just like type stuff into REPL.
Because you ideally when you cannot touch it, yes. So you can write your migrate function and then configure your VS Code for the hotkey.
Yeah, totally. Man, just like press a hotkey, migrate, press a hotkey, rollback. So that's that gets really nice. But yeah, I find like for me, kind of like the REPL is the interface a lot of the time. and I just put aliases in there and erase it to tape.
I usually don't work in REPL, so I prefer the comment block. So for what stuff you did in REPL, I would print in comment block and then just jump to expression and run it. So.
I sometimes, yeah, like I bounce between the two. Like I find like if it's like a little bigger and I'm going to use it a lot, I dump it in the comment block. But I find like stuff, for example, like migrate, right? Like I might be doing it across many namespaces, and then I don't want to just like pepper it in every namespace. I just do it in the REPL. But yeah, both definitely work. And yeah, so the basic idea is I find this kind of setup is really convenient because then you can create those helpers in the user that let you access the resources at dev time. And then when you're developing and you want to do your comment block and play with it, you can just get the connection and use the connection, right? So you don't have to do like go through your handler and the app.
And that's essentially how you develop your endpoints. Yes, so you can call in REPL these commands like work on the SQL query, yes, update it, run it in a comment block, understand that it works, put it into the handler.
Yeah, exactly, right? Like it's either gonna be I start from the controller here, or I guess in our case in the API, where I'll define the endpoint, figure out how to actually make it show up. And then once we do that, then I'll go to see what the params I get, and then start developing, right? Like using the params to drive the query. Or if like it's just a query, right? Like I'll start from the query, build a query, and then shuffle it back to response. But usually, yeah, that's basically the level of interaction, the max level of interaction I'd have in a real app, where I'd separate kind of like the handler from the root, and then the handler gets the parameters, does whatever it needs to do, runs the query, builds the response back. I've come to like using Mali as well, like as a sanity check, especially kind of like at the endpoint. I mean, with Reddit, that's maybe like one nice thing I do have to say about Reddit is that you can add your request response params and use it sort of right like both for Swagger and for validation and coercion. And then that kind of like, right, like when you go to a particular handler, you know, it's like, oh, okay, this takes those parameters, they have those types, right? And then, but again, right, like that's the level where I actually care about types, input and output. And if you don't have like too many hoops to jump through to go from input to output, then you can keep the types in your head easily enough. I find, right, like that's kind of like this thing that static typing sort of solves is like when you have this like very deep nested hierarchies of code and you have this big graph you have to work through and you can't keep the whole graph in your head. And then, yeah, like dynamic language becomes hard to use because it's very brittle and fragile. But if you break things up into small things, then you don't really have that problem to begin with. And you can sort of use that to gauge, right? Like when you work with your code, you know, am I getting lost? If I'm getting lost, then maybe I need to break it up, right? Like maybe that's the time to refactor and to split things up. So use that as kind of like a heuristic to decide if your code got too big and too coupled. And I guarantee, right, like in the real world, like even in complex, large applications, you can always decouple. You can always take a bigger app and break into smaller apps. Like ultimately, the smallest unit of composition is a function. Anything bigger than a function is a choice. So like whenever somebody who is static typing aficionado comes to me and says like, okay, yeah, no, Clojure works for, you know, like applications with like thousands of lines of code. But what if you have millions of lines of code? What if you have like a 30 people team working on the same application with millions of lines? And I'm like, why are you doing this to yourself? And the thing is, right, like it goes beyond code. It goes beyond maintaining the code base. If you have like 30 people working directly with each other, that's a lot of communication overhead, just human overhead, right? Like emails, meetings, Slack. It's incredibly disruptive to work with a lot of people concurrently. It's much better to break things up into small teams of like, you know, 2 to 5 people, have them work on a piece of application and then break your application up into these like small components that get assembled together at a higher level. But right, like I've never seen any arguments for why you would want to structure an application as just one giant monolith.
There are a few other problems with the static typing. So what I found when I analyzed this and researched this, that usually types or classes or objects are very badly composable, and a lot of code really I could not estimate, but I'm pretty sure the more than half of code is just glue of this problem. Yes. So then your project is becoming bigger, yeah, because of this static typing, and people saying, so I need these static types to keep track my huge project. Yes, but the size of this project is because of your types. So it looks like self-created the problem. Yes.
Yeah, it's a self-fulfilling prophecy, right?
Yeah.
Like you create all the types.
Yeah.
And I think like it's even more than that, right? Like it's not even the issue of just the quantity of code, but what happens is like when you work with a type checker, you're restricted to a set of statements that can be validated by a particular type system. And you often have people, right, like you have the debate where it's like, oh, but you know, like this type system can do this, right? This type system can do that. Yes, but no one type system can do everything well, right? You're always making compromises of what your type system can express. And then if your type system can express a lot, then it's complex. And a good example is Scala. Scala has a Turing complete type system. People have written debuggers for the Scala type system, right? And like at that point, when you put a lot of these assertions into your type system, you're creating a program in your types. Part of your program now moved into your type system, and nothing is helping you validate that that's same. And so the trade-off you're making, right? Like you're making sure that the mechanical composition of your component is correct, right? That's what the type system does. It says that the input I got matches what I expect to get. Output I produce matches what I expect to produce. This is a simple mechanical problem. A bigger problem is understanding semantically what the code is intended to be doing and what it's doing, right? And my favorite example is, I think there's like Idris merge sort, right? Like, oh, this one's still okay. This one's still okay. There's a bigger one. Maybe this one. Yeah, right? Like, it's has 32 lines of code. And it's non-trivial to understand, right? Like, so I know it compiles. I know the data will pass through correctly, but for me to tell, well, this thing is doing what was intended is kind of difficult. If I took, right, like 10 lines of Python, that will do it. I will have easier time guaranteeing that the 10 lines of Python do what I intended to do than Iris 32 lines of Idris. Even though, right, 32 lines of Idris are, statically checked, technically beautiful and perfect, and it's a proof. And that maybe is the other thing too, right? Like what you're doing with types is you're writing a proof for your code. And you're baking this proof into your code. I think like possibly like stuff like typed closure, right? Like gradual typing approaches are in a sense better because you can attach them after, right? You can write your code and then you can write a proof for your code later if you want it. And you can keep them separate. You can be like, here's my code, here's the proof that the code works. And I kind of like that similar way I treat stuff like runtime contracts, right? Like Stack or Mali, where it's like, I'm going to write my code in a way that's most readable and most the easiest to understand, and that conveys the meaning to a person the best, not to a compiler. I think that that's the thing to keep in mind. Like code ultimately has to be read by a human and it has to make sense to a human. The fact that a compiler can validate some things is a bonus. It shouldn't be the primary goal of the code to prove itself to a compiler. Because, right, like again, like this thing, compiler is happy, I'm not. That's my assessment on that. And then, right, like I feel like you solved the wrong program when you optimize the code for the compiler's benefit. So that I think that for me, that's the real issue with static typing. If I'm forced to write code in a convoluted way, so I can express it in a way the type system will recognize, that's a problem. Right? Like I should always be able to write code for another person or myself to read it.
Yeah, and another important point that So if we are talking about ideal type system, it doesn't allow you to break the rules, yes, of the type systems. All invariants should work, and this make impossible REPL interactive way, because so we work it now, yes, and we see that eventually the system is an inconsistent state, yes, but it's a transmission to the next consistent state, and you don't want to stop your runtime, you don't want to stop to interact with your environment to just, I don't know, change something, yes, and that's why I usually say that the REPL is the how to say it properly. So it's a final destination. All this stuff in Clojure, like dynamic, functional, immutable data structure, all of these things together allow you to do the REPL reloading code. If you miss something like dynamic and introduce static, so some REPL is potentially possible, yes, but it doesn't work like you could not interact with your runtime, yes. Or if you introduce a lot of mutability, uncontrolled mutability, then again you have a lot of problem, yes. You could not reload code which is full of state, yes. So you just lose your runtime, and that's magic, about the Clojure.
Like I think, like that interactivity, right? Like of being able to basically change anything without having to restart the application. It's very valuable because sometimes you get like unified states. And I think like one thing that's also like worth mentioning, right? Like is keeping your state contained somewhere, like in a variable, right? Like if it's an atom or like an integrand system or something, is really important because like you really want the code you write in the files to be kind of like state free. And you want to inject the state into it, because then you can just flush your entire REPL, right? Like with tools like REPL refresh and just start from scratch. And I find that's really useful, right? Like, and especially like in Clojure, you can get into stale states, like with stuff like multi-methods.
Mm-hmm.
It's really valuable to just be able to say, it's like, okay, I want to flush everything and just restart. I find that's what makes it work so well. But no, it's a really, I find, rewarding experience to work with REPL, because that interactivity kind of, it's enjoyable, right? Like you're seeing things happen as you're building them. You're not wasting a long time to see the results, and gives you that confidence that your code is doing what you want. I find, right? Like every time you write a function and you see it, okay, I get the result I want, I write the next function, I get the result I want, and just kind of like iterate on that. And each time the context you have to keep in your head is the last function I wrote and the next function I'm going to write. And that's it, right? Like I don't really have to know anything else. And then maybe at the end, like I'll do some testing and run through stuff. But that happens like once in a while, right? Like 90% of my development happens very interactively within a small context.
And I like this development when you start with experiments and then you evaluate, do the evolution to the production code with the very, very small steps. So you start playing, then you just extract some functions, and you write the tests, and then you're done. And in other languages, so you kind of forced to be official top down. So you should decide what classes, what stuff, how it's embedded into. So you could not just play with the central part of your problem. Yes, so I don't know. If you don't have to do some report, some complicated SQL, yes, you can start playing right here. You can change some stuff or insert new data, and without losing. And from my opinion, this increase efficiently multiple times. So if we compare with the other workflows, so you can be very efficient. But what I found, that there's a different type of peoples. Yes, some people like to think top down, and some like bottom up. And some like just sit down and think a lot and then just write it down. And I prefer to start from experiments and then make conclusion. Then you definitely should sit down eventually and think about everything you get. But if you experimented, you have much more information to make the better conclusion about how it can be. If you're doing top down, so you sometimes you end up with the first or the second solution which come into your mind, and you stick to it because it's kind of not flexible. Yes, you decided to do these classes, these hierarchies, and then you're in a trap. So you should rewrite everything, or
I find like I see it like it's kind of like having a conversation with the compiler, right? Like you're doing this, and I think like what you said is like really important, right? Like you're doing exploration, like you don't know what your solution is. You don't want to necessarily jump to the first solution that comes to your mind. You want to try different things, and being able to like very quickly change things and see the results, get that feedback, it's huge, right? Like if you have to jump to a separate namespace, write a unit test, figure out the API for it. And I find, right, like what happens is like psychologically, it kind of just calcifies things, because the more code you wrote to do something, the less likely you want to change that code, especially if it works.
Yeah.
Like it's like in Java, when I work with Java, 100 lines of code would be like solving a simple thing. And once you wrote 100 lines of code, you don't want to like rewrite the 100 lines of code. So you just leave it. It works, it's fine, I get tests, let's move on. In Clojure, 100 lines of code is namespace, right? Like you're doing a lot. Like on average, I find, right, like 100 lines of Java can be like 10 lines of Clojure quite often. And if you have 10 lines of code, it's much easier to take that code and to change it and to play with it. You feel less attachment to it, right? Like psychologically. And I think like, right, like to me, that's sort of the combination of features in Clojure that really keeps me with Clojure, is that it's concise. You don't have a lot of code, but it's also fairly simple and regular in terms of syntax. You have other concise languages, but you have to keep a lot of syntax in your head. And now you're thinking a lot about the language, and especially when you work with other people and they use other parts of the language. And there's that joke about C++ where, everybody knows 30% of C++ and it's different 30%. That's what happens when your language is big. So the fact that Clojure is small and focused is a big feature. And so it's concise, it's small, so you don't have to keep a lot of stuff in your head, and it's interactive. So you can explore things, and when you're not sure about something, just run it and see what it's doing and figure things out by trying things.
Mm-hmm.
And that's almost like, to me, a unique combination. That's not really available a lot, especially like in languages you can kind of use in production.
Yeah.
Like obviously like Lisps, yes, but like good luck finding a job with common Lisp. Some people are lucky enough. Most people aren't. Clojure is probably like the most realistic way to get that sort of development experience in real production code today.
Mm-hmm. Another interesting thing I found that Clojure forces you to write more generic code. So because when you're thinking with the function in data, so you're thinking almost at the top of generality, yes. So and it doesn't force you some records or some abstractions, some interfaces, and eventually, you can go quite high in level of your abstractions. And then and everything is still composable because it's data, yes, and like generic data structure, and all of them are composable. And you're reusing function, and that's amazing. That, for example, I did investigation, so we developed the Fire server, yes, implementation in Clojure. It's closed source, but okay, there's some open source in Java, and the difference in code base was like more than one order magnitude, and we could not say that you can get one order magnitude just because of syntax. Yes, it's not syntax stuff. It's how you compose your program, how you make decisions, and that's only possible if you do more generic program.
Yeah, and I find like a lot of the abstractions you see in languages, they seem like a good idea especially when you're learning classes, objects, grouping things into types. It's one of those things that just on paper sounds really useful and good, that you should be doing. It's proper. But then, like when you look at real code, when you work with code in the real world, you find it's not really doing much for you. What you really want is, you're pretty much every program out there just does data transformations. You get some data as an input, you change it in some way, and you produce some data as an output. That's what a computer program is. And focusing on the data transformation is really what gives you that abstraction, right? The proper level of abstraction, in my opinion. Like everything else, it just detracts from that, and that's complexity. And then you end up with code that looks really clever and maybe proper in some way, but it's hard to work with. Like that's ultimately what we want is code that's easy to understand, easy to modify. And when you're just working with plain data structures, that's what you get. I think another big aspect with Clojure too is immutability. That if you look at Clojure library APIs, they're always data in, data out, and it's immutable data. And if I'm trying to figure out how to use the Clojure library, I start up a REPL, include the library in my project, pass it some parameters, and then get a response and see the response in REPL, and I see what the data is. And that's it, right? That's a contract. That's all I need to know about this library, and I can use it effectively. It takes minutes to do. If I'm working in a language, say like Java, where you have classes, what do? I find, like a class that I need to call, and I have to figure out how to instantiate it with a constructor. And then its API is object graphs, right? So now I have to figure out, to call this class, to call a method, I have to pass it a different class, and that class takes another class, and takes another class, another class. And each one of those classes is its own DSL effectively, because its own behaviors, its own methods. And the amount of stuff you need to know now grows exponentially. And then on top of it, it's mutable and stateful. So what you end up when you work with object-oriented APIs is you end up with this object graph with a bunch of state machines that are interdependent, that all affect each other, all talk to each other. And you have to know, right, like how to get in a particular state to do the thing you want. This is a much harder problem than just taking a piece of data, passing it through a function and gets a new piece of data. Like your data is transparent, it's inert, and it has no behaviors. It has nothing you need to know about it. Like you're using the same functions from your core library to manipulate the data every single time, no matter what shape it has. I think that's it's really important, this idea, right? It's basically the whole Unix philosophy. You have a bunch of functions that operate on a common data type and just pass the data through. And the only difference in Clojure is that you have rich data types. Instead of just working on strings, you have maps, lists, other primitives. But it's basically Unix philosophy in action, in my opinion.
Yeah, I usually joke, like, if you get this idea of data-driven development with a generic data structure, so you're like getting into the matrix. So you see the world like consisting only digits, yes, zeros and ones, because eventually understand that everything and mostly everything what we do can be expressed as a manipulation of generic data structures. Yes. So the request is a data structure, the query to the database data structure, the workflow rules data structure, everything is data structure. And yeah,
it becomes like your life becomes simpler, right? Because I think again, like the idea of having the right abstraction that minimizes the context. And again, right, like it goes back to this whole idea of context. Like why is having more abstractions on top of data problematic? Because it introduces more stuff for you to think about, more stuff you have to keep in your head and to contextualize in order to work with the application. And right, like the more barriers you reduce between yourself and the data, the thing you're actually doing, then it becomes simpler. And it's really interesting, right? Because like even in terms of just like performance, security, all those things ultimately are much easier to ensure when you have less code and more direct code. If I get a request and I have a handler and I can see what the handler is doing, now I know what's happening. If I'm going through some framework like Spring or Rails and goes through 1,000 functions before it gets to me, I have no idea what's happened, right? Like and at that point you just have to kind of like take things on faith, right? You hope that all those libraries and frameworks and everything is just implemented correctly and it works well and so on. Whereas if you just have a little bit of direct code, then you can sort of I think that's the other part too, right? Like you could the ability to read code and know what it's doing just by reading it is really valuable. And I think you can only do it in the small, right? You can only do it when you have a small context, you have right, like a pure function. You can read a pure function, understand it completely, and know exactly what it does. But as soon as you have things like mutable state, references, and so on, you can't really understand the code. You kind of have an idea what it's doing, but it's heuristic. And that's why you need a debugger. If you're working with Java, only tool you have is, put a breakpoint, get your program in a particular state, inspect that state, and go, it's like, oh, okay, that's what's happening. But you're never guaranteed that's the only way to get in that state. It's just you found one path towards it. You can't really make guarantees about your code anymore. So everything becomes a heuristic at that point.
Yeah, but to be honest, then is a problem which is not solved by Clojure by themselves. Yes, so we still, if we're working with a big code base, so the getting the structure of the application still problematic. Yes, so the code is not transparent. You should read this code, yes, and every line of code can bring some surprises. So well, we had a conversation with a guy who is forcing this category theory, Bartosz Milewski, on some conference, and we end up that these experienced guys, when they working with a type-driven programming, what they're trying to do, they try to shape the whole program into some regular structure. So get this structure which is more static and more transparent than the code. Yes, because yeah, and for the Clojure, it's still the challenge how to understand these big. I don't think it's related to the Clojure. Yes, it's related to all the code bases. So how you structure this code, how you still keep the control over what's going on. Yes, you said it can be split into small pieces like services, yeah, but still some reuse, some conventions, some complexity, and it's kind of distributed across the code base, and there's still a lot of mental load. Yes, so and we see that Integrant trying to express some piece of structure, the structure of your program as a data. Yes, and this is kind of, I think that's what people which are forcing type-driven development keep in mind as well. So they. So when we talk with them, he said, I'm thinking about my application, about my program until I see it as a data structure, yes, as some specific type. And the type helps these guys to think about the design of application, yes. But it's hard to achieve it, yes. And I don't think that Clojure could not do the same with the data structures. And we see that Integrant is trying, yes, all these data DSLs are trying to kind of create this regular view of the program, which we can understand.
Yeah. I think like it's still kind of a thing we're exploring right now, right? Where we don't really have a good solution yet. But I would argue, right, like it's partially an artifact of the whole software industry being very new right now. We haven't been doing it that long, especially on this scale. I think large, complex applications that are long-lived, developed by large teams of developers, that's maybe happened for the past couple of decades, like where a lot of people started doing that. Maybe let's say like since 80s. Like obviously there have been large applications written before, but still, even if you go back to 70s, That's still not really a lot of time, like compared to a profession like engineering, for example. It's thousands of years of tradition. We're still basically discovering how to write good code, how to structure applications in a way that we can understand and maintain, how to break stuff up. And I feel that a lot of people kind of jump on these things, right? Like, oh, we'll make it object oriented. Oh, we make it statically typed. Oh, we do this, we do that. And they just convince themselves this is the solution. And we don't know that. These are all experiments. We're all trying stuff. And I think one of the things I look at is if one style was definitively better than others, we would just see it dominate. But we right now, for example, static and dynamic typing, see a lot of code written in both, and there's no real hard data showing that static typing is definitively producing better results. In fact, there's a lot of studies showing kind of the opposite. So yeah, maybe static typing provides benefits. Maybe it provides benefits in a particular context, like you're writing a compiler. I would actually argue that static typing makes more and more sense the more of the work your application does is internal that you control.
Mm-hmm.
The more you interact with outside world, the less benefit you get from static typing, and the more hindrance it can become. And ultimately, you can't control everything, right? Like I feel like a lot of time when people focus on static typing, they want their program to be perfect out of the box at compile time.
Mm-hmm.
But I think it's much more valuable to focus on your program being resilient at runtime. How you handle errors.
Mm-hmm.
Can you do it gracefully? Can you really, right, like have your program recover from an error? Can it handle like nulls, for example? Can it handle? Because what's going to happen is very like again, like going back to the whole idea of you not controlling things. Maybe the service you talk to changed their API. The other team decided to add a flag, remove a flag, whatever, right? Like
Yeah, the world is dynamic. Yes, so that's true.
yeah. And you can't know at compile time what the state of the world was going to be like when you run your application. Your database could go down, right? Like your data center can get disconnected. All those things will happen. And if your program recovers gracefully, like for example, with Clojure, we can connect a REPL to a writing program in production. And then we can change things at runtime. And right, like we can structure it in ways that handle errors gracefully and retry and so on. But none of it really has to do with trying to catch all the errors up front. It's almost like a fool's errand to try to do that.
Yeah. Yeah, I mean, so if we think that static types, it's a kind of metadata about your code, yes, and the compiler can use it to prove or disapprove something. Yeah, in case of Clojure, we have a lot of data DSLs, which essentially is well the metadata about some algorithm or some programs. Yes, and at that point, I think then kind of getting to the same point potentially. So if we're taking like type-driven development for the structuring application, yes, and the data DSLs from the Clojure world, which are trying to separate this declarative part of your application from imperative. So I'm like last 5 years I'm thinking about what even more I think like about model driven system. Yes, when you can separate the system into the model and into the interpreter, and the model can be much more regular, much more static, and much more visualizable and understandable, yes, comprehensible than the code.
Yeah, for sure. Like I think I really like the idea nowadays of sort of treating my program as a compiler for the data. So the data is the API. It semantically describes what I want to do, the input output, and I pass it to a function and it instantiates whatever it needs to do. Like I think like a very good example of that. Let's say you're doing the UI and you're building widgets. You can describe your widget as something like type input, label, right? Like foo, and whatever, right? Like on, or maybe, like let's say it has like a pass in the document.
Mm-hmm.
first. Let's say we have something like this, right? Like I look at it as like I can pass it to a function, right? That could be like something like def input. It's going to take this, right? Like keys, where it's going to be type, label, pass, and it'll compile me a structure, right? Like say we'll have like a div with label, input, right? And then we do all the stateful stuff, right? Like type text, value is going to be like whatever else. Value, right? Like if you have like reagent or something, and then on change, right? Like reset, value, pass, or whatever, right? Something like that.
Yeah.
A sock. Like say we do this, right? And this basically, right, like this will instantiate a component at runtime that represents what this is describing.
Mm-hmm.
And it's very easy to see kind of like with UI elements, but you can really apply this principle to anything. And then your API becomes this kind of like semantics thing, and all the implementation details and all the boilerplate is hidden in those things. And then when your program starts up, you feed it the specification, it parses your specification and instantiates whatever it needs to instantiate.
Yeah, and the magic of this that you potentially can write another implementation, for example, I don't know, for some generating, I don't know, for mobile application, yes, not using HTML, but using native widgets. As well, you can, because of this data, they're quite regular, so you can analyze, like, go through this data and ensure some invariance or generate documentation from it. Yes, there are plenty of stuff you can do with this. Yes. Check that path exists in a definition of the schema. So
another really good aspect is you can serialize data. Like I often represent the state of the application as a map and just dump everything in that map and then just serialize it to Postgres. And then when application restarts or whatever, you just pull your state and resume.
Yeah. And the next step potentially maybe allow user to define such type of stuff. Yes, just through the CRUD, the user will be able to extend your application with extra logic, like defining new forms, defining new tables and entities.
Yeah, for sure. Right? Like it becomes like like you can get like different levels of people to work with the application, and then maybe you have some junior developers whom you don't necessarily want to work with the guts of the app, and then they can work on this DSL you built, while like more experienced people work on the implementation. I think the other thing is reusability, because once you end up aggregating the set of those components, Lego blocks, and then you can reuse those Lego blocks. Because if you decouple them from context, like a good example would be, say, email sends. You could have a function that is tied to a particular email address and particular workflow, or you could have one that just knows how to send emails and that accepts the data structure that tells it, like from to whatever, right? And when you do it that way, then you start building up those reusable components that you can easily recycle. So it's like kind of like, like try to keep your context, your business workflow separate from the implementation as much as possible. Like you can get like too far with that too, right? Because the flip side is like when you have something like hyper configurable, it also becomes unreadable. So it's like knowing when to stop is important.
Yeah, but at least it's quite cheap to create DSL enclosure, like data DSL. Yes, so
yeah,
and there's a hope that your third DSL will be not so ugly. Yes, so you can experiment a lot, and you can use your REPL to experiment.
For sure. Like I thought, and it's interesting how when people started using Clojure, we saw a lot of people doing macros, and like, as a community, I think like we kind of like moved away from that. Right, like now people tend to make DSLs, but they make them using data structures.
Mm-hmm.
And that's been an interesting change, in my opinion, because like in common Lisp community, for example, right? Like macros are still very popular, and they can like look down on Clover people for not leveraging macros as much. But I find macros introduce complexity. Macros mean you've introduced new semantic behavior for your code, right? Whereas if you have a function, we know how functions work. We know what the expectations are. But if you're reading a macro, one problem is it looks like a function, but maybe doing something completely different from a function. It can pause execution, it can inject stuff, it can change the payload, it can do side effects. You just can't know without reading it. So I find being very conservative about use of macros is a good idea. And expressing your DSLs using data that is parsed by functions is much better than using a macro-based DSL. I think we can see, like, for example, like Reddit versus Composure, right? Because like Reddit came out later, and I think this lesson was already learned. But like and there's a bit of that, right? Like easy versus simple again, where Composure is kind of easy to use, but there's a lot of magical things that happen once you get to more complex things you're trying to do with that. Whereas Reddit is a bit more verbose, as we said earlier, but once you spend like 15, 20 minutes to figure out how to lay it out, then it becomes like pretty easy to work with. But now it's genuinely simple because you just have this data structure. You can look at it and understand what's happening.
Yeah, I mean, maybe some news, maybe some new open source libraries or stuff like this. What can you announce?
I guess I'm gonna pitch the whole kit.
Yeah.
GitHub.io. We actually have a little video that explains kind of like rationale, and there's a bit of a demo at the end that actually works. A bit better fleshed out than I was doing today. So if people are interested, definitely give it a shot.
Mm-hmm.
And yeah, and like for other projects, I think like most exciting thing for me right now is Babashka. And it's just like it's completely changed my workflow because now stuff that just, the startup time wasn't really worth the buzzer. Now it opens up all those opportunities. And it's kind of batteries included because you can do HTTP calls, you can talk to Postgres from it. So it's kind of like most of the things you really need to do in terms of service interaction.
Okay. Thank you, Dmitri.
Thanks for having me.
Nice to see you. Yes.
Bye.
Bye-bye.
Bye.